Why, yes, of course. My name is Sir Arthur Eddington, and in our experiment, we used the position of stars in the night sky to help prove Einstein's theory of general relativity. Well, our goal in this experiment was to find out how much light would bend when passing a large mass. This result would either help prove or disprove Einstein's theory of general relativity. We did this by first measuring the position of the stars in the normal night sky. We then waited until the May 29, 1919 solar eclipse, during which we used our 5 minutes of time to measure the position of the stars, again with the sun up. By doing this, we could tell the difference in the position and measure how much light had been when passing the sun. It was imperative that the weather be clear in order for us to take our measurements of the stars. It was also important that we measure from within the path of totality, the area of which the sun is completely covered by the moon. In order to make sure both of these things happen, we sent one team to Brazil in the town of Sobral. We sent a second team, which I attended, to the island of Principe, right off the west coast of Africa. Given that the year was 1919, the Great War had just ended and the treaty had been signed. Actually, in 1914, another team had attempted to do the same experiment as us. However, the outbreak of the Great War caused them to miss the solar eclipse. Well, many different people were involved in the project. The two lead researchers on the team were myself and Frank Dyson, the director of the Greenwich Observatory. Dyson also sent two of his staff to the Brazil expedition. Meanwhile, myself and my fellow Edwin Cunningham attended the island of Principe to take our measurements. As one of the two lead researchers on the team, I was responsible in part for planning the expedition. However, my main responsibility was taking the measurements off the island of Principe. I also analyzed all the data that we collected on this expedition. Our experiment has helped prove general relativity, which was our original goal. General relativity has completely revolutionized how we perceive both space and time. It's changed physics fundamentally forever, as we have been basing much of our ideas of physics on the laws of Newton. However, Einstein's new theory has brought us into a new age of physics, and our team was one of the first teams to be able to show observable evidence that this was a true fact. As with any big breakthrough in physics, our results were somewhat divisive, to say the least. We did have to throw out some of the results from the Brazil team's expedition, as their telescopes had become warped and their data became useless. However, this has led some to accusing me of throwing out data in order to support Einstein's theory, as I was a known avid supporter of it.